Hi friends, earlier we discussed about the limit sin 1 by x when x is tending to 0. Right. We have discussed that sin 1 by x fluctuates a lot when x approaches 0. Now what about this limit x tends to infinity sin 1 by x, and how is this different from x times sin 1 by x tends to infinity? Obviously sin 1 by x, sin any function will always lie between 1 and minus 1. Right. But when x is tending to infinity, what will happen? When x is tending to infinity, obviously 1 by x will tend to 0. So it is straightforward, little bit straightforward, right? This becomes sin 0. So ideally it should approach 0. Okay. But what about this one? So x is tending to infinity and this sin 1 by x is tending to 0. So we are looking like some peculiar case, infinity into 0. What exactly is it? Is it 0? Is it infinity? Is it something else? Let us try to resolve both of these cases. Okay. Firstly, sin 1 by x. We discussed the graph is like this. We agreed that when x equal to 0, there is no limit because we cannot clearly restrict between 2 points between between two deltas x plus delta and x minus delta, the entire graph, right? Basically what we are trying to say is the graph is not continuously approaching any single value. It is neither approaching 1, it is neither approaching minus 1 or any value in between. So for a limit to exist, what we mean to say, from the left hand side, from the right hand side, the graph should approach a common value, and the distance, and it should approach as close as we want. For example, if you say limit is 0, then the graph should approach as close to 0 as we want, and within some range of x minus delta and x plus delta, the entire graph should always lie within the range of epsilon that we are giving. So let's say we define this epsilon like this, within some range of x minus delta and x plus delta, that is 0 minus delta and 0 plus delta, entire graph should lie in this range. Clearly it is not lying in this range because this part is above, this part is not there. So whatever we do, whatever delta that we take, the graph will never lie within these two horizontal lines. So there is no limit when it is 0, when x is approaching 0. Now, clearly we can see when x is approaching infinity, right? 1 by x is tending to 0. Obviously, the graph will be approaching x-axis, right? Both on the positive side and the negative side. So here we are concerned about positive infinity. That's why, and this is 0, and at the same time, right? Here, x is tending into infinity. Let's say 1 by x, we call it as t. What does that mean? T is tending to 0 plus, right? Because this is positive infinity, this is 0 plus. And 1 by x is t. We can write it like this, right? That means t is tending to 0, sin t is obviously 0. Okay. Now, what about this case? X sin 1 by x. X is tending into infinity, sin 1 by x is tending to 0. How do we resolve this? Right. Now, here also, let's assume 1 by x is t. Okay, this x we can write it as, this x we can bring it downwards and we can write it as sin 1 by x by 1 by x. We can cancel it here and we can write it like this. Now if I call 1 by x as t, this becomes t tends to 0, 0 plus, because this is positive infinity, right? 0 plus, and this is sin t by t, which is nothing but this graph. So earlier we derived for sin theta by theta, sin t by t, whenever this theta is approaching from this side or this side, doesn't matter, it is equal to 1. So we have cleverly converted this equation to sin theta by theta format when theta is equal to 0. So this is actually equal to 1. Similarly, if you do for minus also, if you do for x equal to minus infinity, then again t tends to 0 minus, from this side this is still 1. Okay. So now x sin 1 by x, the limit is actually equal to 1. You can see it from this graph. The graph, there is a horizontal asymptote, right? The graph will look like this, x sin 1 by x. As x approaches infinity, this graph, it will try to approach 1, right guys? It looks little peculiar, right? Product of some big infinity, and some small number is actually tending towards 1. It looks little peculiar, right? So we have other reasons to believe this also. When we know sin x tends to be x is almost equal to x for very small x, when x is very small, right? We have earlier also we have discussed, when x becomes small, if we take the circle, then what is sin x? This is theta, and the radius is 1, then this is sin theta, right? And this is theta, right? This length is r theta, right? R is anyway 1, so this is actually equal to theta. Now, when this theta becomes smaller and smaller, this line will come here closer. So basically, it is this line versus this r, small line versus small r. So the length will come closer when theta becomes smaller, as long as theta is in radians. When theta is very small, sin x is almost equivalent to x. Here, x is tending to infinity. What does that mean? 1 by x is tending to 0, right? Obviously, if 1 by x is very close, then sin 1 by x should be sin 1 by x. 1 by x should be very close to 1 by x. Right, because sin theta is very close to theta, sin x is very close to x. We have just decided, right? This height is sin theta, and this length is theta. This arc, length of this arc. Right, now when theta is very small, then this line and the length of this arc will be very close. Right, obviously sin theta is always lesser than this arc, right? Because here we have a right angle triangle and we have an arc like this. Obviously, this side is always smaller than the hypotenuse because this is a right angle, right? This side is always smaller than the hypotenuse, and this hypotenuse will always be smaller than this arc, right? Because this is the straight line joining 2 points, and this is a curve joining 2 points. Obviously, sin theta will always be less than theta, right? Will always be less than theta, and but the distance it will get closer because as we move this line towards this side, the curve will become shorter and shorter, and line becomes shorter and shorter. Then that will be equal. So, for example, if you put, if you move, if you increase the theta, right? Then sin theta is this, and the length of curve is this, right? And then there's a huge difference, right? Because the as you walk more on the curve, the distance increases, right? Now sin 1 by x will be closely equal to 1 by x because 1 by x is very small. What does that mean? X into 1 by x, this is equal to 1, right? This is another way of looking at this problem, right? So sin 1 by x will be almost similar to 1 by x because 1 by x is actually very small. Instead of being thinking like x sin 1 by x is like infinity and this is like 0 and infinity into 0 is 1. Instead of thinking that way, we should think x is very big, however, doesn't matter because sin 1 by x is very small. So 1 by x tends to, sin 1 by x will be like 1 by x. So that's why the product is equal to 1. Right, guys? So hope you like this. The limit of sin 1 by x, right? This we realized it is tending to 0, right? And x sin 1 by x, this we realized it is tending to 1. And so x sin 1 by x is actually a slight variation of when x tends to infinity, sin theta by theta when theta tends to 0. It's just a variation. It's written in the inverse form. Right, guys? Hope you like this. Thank you.